Hi, this is Snail. I'm teaching probability. This is my second lecture. Let me remind what is probability. Probability is we are talking about the chances basically. So, to define probability, we need some terminology. First is sample space. What is sample space? If you perform any experiment, then what are the possibility of outcome, or we can say collection of all possible outcome is the called sample space. So sample space is the set of all possible outcomes of an experiment is called sample space. For example, if you toss a coin, so if we tossing a coin, there are only two possibilities, either it is head or tail. So S is the collection of head and tail. Or suppose example 2, if we are tossing two coins, so what are the possible head uh, on a face of one coin it may be head, and on another coin also head is showing up. Head, tail, head, tail, and tail, head. These are the only possible outcomes. So these are the example of sample space. So you can also construct several outcomes, all possible outcomes for any choice of your experiment. Another thing is event. What is event? Subsets of sample space. Called event. Meaning, suppose I am taking example 1. Here we were tossing one coin where sample space is head, comma, tail. So what are the subsets of S? Is phi, H, T, and the whole HT. So these are the events of S. In example 2, all subsets of this. So all subsets, for example, I am not writing all subsets, but few of I am writing, and likewise. So these are the called events. So in simple language, events are nothing but the subsets of sample space. Whenever we perform an experiment, we need some particular type of events. For that, we are going to calculate our probability. So we are not going to take all subsets of S, but what in question, what is in demand, that event we are going to take, and that event is definitely going to be a subset of sample space. Alright. After that, I would like to develop the theory of probability. It is based on some axioms. What these axioms is, let S be a sample space and E be an event. Let P of E be some number which is well defined and satisfies following condition. Following axioms. Axioms means which we cannot prove. We are going just assume those points. That is called axioms. So first one is this PE is always in between 0 and 1. Second, P of sample space is always 1. And third is if E1, E2, so on, En, so on are events such that EI intersection EJ is empty for any I not equal to J. If EI intersection EJ is 5 for I not equal to J, then P of E1 union E2 union En union so on is nothing but P of E1 plus P of E2 so on, P of En and so on. Alright, simply what I want to say is P of union I running from 1 to infinity EI is nothing but summation of probability of EI running from 1 to infinity. But under this condition. So this condition, whenever even satisfy this condition, remark for EI intersection EJ is 5 for I not equal to J, then E1, E2 and so on, En and so on are called mutually exclusive events. So whenever the given events are mutually exclusive, then when you take the union, it gives you the sum of P value of EI. This P of E we call the probability of event E. Event E.